Hello, everybody. So I'm here to give you a brief tour of how to use Panda and POSSUM. So a bit about Panda. Panda was created in 2008 um, by past Canoe hull design leads, and it's basically a program that designs a concrete canoe hull for us. So some teams, if you've read your technical reports, around the US and Canada, you'll know that a lot of teams just design it solely through something like FreeShip or DelphShip or some sort of naval architecture software. Um, but that's a lot more time consuming than this process. And Panda is specifically designed to design a canoe, first of all, and not only design a canoe, but design a concrete canoe that fits within the specs of the rules. Um, there's some limitations to Panda. Like Panda is geared towards only creating a certain shape. Um, so again, some more background research. If you did your background research, you'll see that a lot of teams, especially in the U.S., they've I think Cal Poly is notorious for creating a tumble home design, but there's also teams that like to use a V-shaped canoe or a flat bottom canoe, or even more creative designs like a really round canoe. Panda will generally give us a really U-shaped canoe, which is kind of a compromise between a flat bottom and a uh, round canoe. So, but there's still a lot to work with in that U-shape design, and U-shape designs are really versatile, so that's why it's used to create it. And they've given us a lot of success in the past 10 or 11 years making canoes. So it's a bit of a background of Panda. So Panda will save you a lot of time compared to what these other teams have been doing. And I encourage you to keep looking for ways to improve Panda. Obviously, you'll need to learn how to code, but this is where we can make some really uh, technical and innovative strides in improving our capabilities because we have this program that no one else in the world has. So right here, I have open a folder, um, and this is probably what you're probably going to be working with, and this has pretty much um, all the required files for Panda. So right here, the creator CPP, this is, you might not have access to this, we'll see, but it has the um, source code of the, the Panda program, and it's 1,600 lines of code. Unfortunately, there's no comments, but you can, if you have enough coding background, you can see that it's very simplistic stuff in the way it's coded, and you can sort of make out the equations. Panda's fundamental comes from this document, and this is basically how they get the canoe shape from what we enter as numbers in Panda. So basically what happens is Panda will create about a lot of lines, and these lines are governed by an equation. And just like you learned in your high school graphing math class with your graphing calculator, this basically does the same thing. And we already know set equations of where the points are, and etc. Um, so that's a really dumbed down version of how Panda works. To be honest, I don't even know um, how the equation works or the fundamentals of the equations. If you're familiar with splines in Illustrator, etc., it's sort of how this works. So I recommend just do way more research into splines and naval architecture equations in general, just so you have a basis to move forward from. So another thing I have to go over, Panda uses TXT files, and what they are is that you basically have to open up with Notepad, and they're basically, this is probably a bad example of one, but they're basically just files that are just filled with text, and to determine the columns, it's used, sometimes they use tabs or sometimes they use commas. It can convert TXT files into CSV files really easily, and then you can just open it in Excel. Actually, this is not the correct way to do it, but yeah, you can still open TXT files in Excel with no problem. So I'll just show you an example of how to do this. And I recommend you, if you're not familiar with TXT files, it may be worth knowing how to open them using Excel. So I'm just going to show you this just because I know some of you may not have this kind of experience. You just go all files, and then you want to check it's delimited. That means that there's something splitting up the text into different columns. And in TXT files, it's usually tabs, and Excel will just automatically separate it out into columns. So if you want to do it that way, you can do it. Just make sure you save, when you save the file in Excel, it's back to TXT, not XLSX, not CSV. Just make sure it's saved back to TXT. All right, let's get down to the files then. So there are documents. This one's on the drive, like the PANDA stuff. It tells you what each variable means. I'm not going to go over it because this is something you should read in your own time. Just going to go over the files. So the C4 table, you have to have in the same folder as the exe program. And this is true of all the files here, that you want to have all the text files and the POSSUM Python script in the same folder as the exe file. So C4 table, I think this is a stats, required for some stats analysis. Input setup, I'll get to a bit later. Output is going to be whatever results your PANDA analysis will have. And then I think most important is the weighted table. So this is a weighted decision matrix, and you have your different categories. So you have your target value, standard deviation, and how much weight you're going to give it. So in this case, we said weight was, or mass was sort of important, so we gave it a 1.25 rating, but in that similar vein, drag is a more important variable to us, and paddler center is a less important variable to us. So research all these variables with the documents we have on the drive. You also notice that some of these weights are set to 0, and that's because these variables are for the 3-paddler load case, and these variables are for the 4-paddler load case along with weight, which is universal. So we don't design for the 3-paddler load case anymore, and that's unfortunately something that's hard-coded into PANDA. But the 4-paddler load case was always something that we designed for, just because the 4-paddler race is always going to exist in some form or another. So yeah, I'm just going to do a demo run. So this is, you open up a program, and it's going to give you this menu. So to do PANDA, the way PANDA is supposed to be run, in the past, before around 2018, usually you change your input setup file. So if you've done your background research, you'll know that this column is your lower bound, this column is your upper bound, and this column is how many variables within the 2 bounds that you want PANDA to search. So I'm just going to give some numbers just for the sake of this. So let's say we want a canoe that's like 5.1 to 5.5 meters, paddler box of 2 to maybe 3. Search 4 times. Let's search 2 times. Deepest point, I'm just going to keep it at 7 just to uh, speed up the processing. Length to first paddler, I'm going to put it 1, 0.5, and maybe we'll put like 2. W, so nominal width, not actual, so which is not the same thing as real width. I'll get to that later. Let's put a 0.65 and maybe 0.7 as our upper bound. Smooth this in the front. Let's do 1.5 and 2. Rear smoothness, let's keep at 0.7. Depth, let's keep at 0.35. Again, I'm just typing random numbers, but I also know intuitively how Panda will probably respond to these numbers. This is just for demonstration purposes. So we got our bow rocker at 16 centimeters, stern rocker 0, which is pretty typical. Flare angle of 10 degrees. Curvature of 0.9. This is a Panda specific variable. It's not, there's no units to this. And density, so this density is not actual density, it's thickness times density of concrete. So you won't know, to be honest, what this value is because concrete design is way later in the term, but I think a conservative number would be 16 because usually we can't really cast below 14 mils or 15. Yeah, 14 mils, and concrete was generally around 1,000 kilogram per meter cubed, so we'll just keep it at 16 for conservativeness. So yeah, so now when you open Panda, this is the UI, and you basically have to type in numbers to select and what option you want. So we're not going, so to do this efficiently, in the past you would go select bulk, analyze several canoes, and then you select analyze for input setup file. So let's just go ahead and do that. Press 1. You can define it in the program, but having it as a separate text file, you can have more control, and it's important that you document all the history that of runs. So what you started out with and what the results were. So let's press this, and you can see that Panda analyzed 96 different canoes. And where does 96 come from? Well, it comes from 4 times 2 times 2 times 3 times 2 times a bunch of 1s. So this is what makes Panda really efficient, because we can analyze a bunch of canoes very quickly. Now, if we want to do this again, the problem in the past is that it's really hard to find what the most optimized canoe is. So there's one method. You just straight up brute force it, and by making Panda try to analyze all possibilities. So that meant you would need to change this. Let's change some numbers again. We're just going to increase how much canoes Panda will create. There we go. So if we do this, this Panda is going to analyze a lot more canoes, and theoretically, we should be covering all of our bases by having Panda analyze all canoes. All the possibilities of different canoes. So And now this is the problem. So because we did this, like Panda, it's going to it does not scale linearly with canoes. So it's going to take an exponential number of times to actually analyze all the possibilities. And we didn't really increase the numbers by that much, but if you try to brute force it, I'm just going to calculate how much different canoes we forced Panda to run. So 7,200. So this is not even extremes. There were stories of like over 1 million canoes analyzed in 2013, but this will severely slow down your productivity. So I'll get to the better method a bit later. But for now, we'll just watch this go. So once you enter those variables, Panda will create an input table file. And this will, well, actually there's 57,000 canoes. We probably missed a number somewhere. But this will basically find out all the different combinations of the different variables you enter in the setup file. And it'll create each combination. And then Panda will analyze each combination and output the results in the output file. So we're just going to look at the output file in Excel just for readability. That was not the right file. Okay. So in the output file, you have a bunch of numbers. It doesn't seem that it might scare. So this is also another problem with the old method, is just too much numbers here. But it's actually related to the weighted decision matrix. So you have so each column corresponds with a different row. So the weight is the first row, and you can see the different canoes. They have varying weights around like 60 kilograms. Some of them may be a bit heavier. Very few of them are lighter. And then it'll go down to the different variables. So remember that basically these columns here don't matter because they're for the 3 parallel case. So you can see the prismatic coefficients. They're all around 0.6. And then the, let me check this. Then the freeboard, drag, stability, leak angle, second moment, power center. And then the last column here, this column right here, this is how much points it awards. So it's hard to tell what this means, but this is basically like how well the canoe performs. So a higher number means it's the best canoe that you created. So, and you can only have as much points as how much weight you give it in the weighted decision matrix. So we can see that canoe 11,517 is the best canoe. And this is also a link to the input table file earlier. So if you open this back up, if we want we go to 11,517, we can find out the exact like variables that were used to create the best scoring canoe. So right here, so it's got a length of 5.1 meters, paddler's box 3 meters, deep is 0.7 meters, first paddler 1.5, width 0.7 meters, etc. In general, most of these canoes, they scored okay. Like, I think the max score is around 10. I was just doing some quick maths there. And PANDA, it's still running. So imagine like running this for a million canoes on your Windows, and it doesn't really save. So it might end up crashing if you from not memory. So this was how PANDA was done in the past. So another flaw was that you know what the best scoring canoe is, but that's only according to this weighted decision matrix that you have right here. So really, like, it's really arbitrary what kind of importance you place on these variables. So you as a hull design lead might think that drag is the #1 variable that you have to design for, but your paddling lead might disagree and might say it's stability or turnability. So, and you want to provide options to your paddling lead because that's the person who's going to be in charge of paddling the canoe in end place. And chances are, it's great if you have paddling experience, but if you don't, then you want to offer as much options to them as possible, and also offer as much options to the structural team to make sure that if one canoe has debilitating like flaw, then we have backup options. So what the new process is, it's a much more efficient way to do this. We're not going to run PANDA on another 40,000 canoe designs, but basically you have your weighted decision matrix, and then for a single weighted decision matrix, you want to get your setup table ready. We're just going to like set it up. I'm just going to type in some numbers that I pre-planned. And what's key is that you want to make sure that the rightmost column is set at 2 or 1. So 1, it means that you want to fix this variable at 7 meters, but 2 means it'll only test the lower bound and upper bound. So this is going to be a more efficient way to look for variables. So I'm just going to set up the setup file for you. Yeah, that looks good. And these ranges, like, they could be as wide as you want, but the key is that this column, like the last column, has to be either 2 or 1. So I'll just save this. And then we're going to use this script called POSSUM. So another program created within a club. It's a search algorithm, and I'll just open this in Visual Studio just so you can see the code. And basically says, or not, it basically, you have all these code, but it basically repeats the same thing over and over again. It basically tests the upper limit and the lower limit, and then whatever Canoe performs the best, if upper value performs the best, it'll rewrite the setup file for you instead of you having to check the Canoe or the output file or the table file yourself, and we'll rewrite the setup file so that you can just click on, just press a few buttons, and it'll get to your final optimized Canoe a lot faster with the same results. So I'm just going to demonstrate how this works. So this is the process I want you guys should be doing with PANDA. So first we have our setup file, and we just want to open PANDA, and then we're just going to do the same thing as before. Analyze from existing setup file. So this was quick, or relatively quick compared to analyzing 40,000 or 50,000 canoes. It's only going to analyze about hopefully 2,000. Oops, I think I did something wrong. Probably forgot to save. Let's try that again. No. Oh, I see why. I have to delete this. So I think yeah, there we go. So the problem was it had the old input table file, so it just was locking everything. So once you got your results here, you don't need to do anything. You just run this Python script, and it will automatically rewrite. You can see the setup file. Now the variables have changed a bit. So this is what so POSSUM automatically found what the best scoring Canoe is, and it's now narrowing these upper bound and lower bounds to like narrow your search down. So it's just a matter of pressing a few buttons. So we're going to bulk analyze canoes again. POSSUM is going to, or PANDA is going to analyze again, and then run POSSUM. And then you want to check your setup file, see the numbers change, and it has. And then do this again. So I'm just speeding through it. Eventually it will get to a point where now you can, yeah, so this is what I'm talking about. So last round it analyzed 128 canoes. This time it's analyzed down to 32. And this is because some of the variables have now converged to a point where we already, like this one, curvature, before we wrote 0.7 as lower bound, it's now converged so that 0.9 is always going to be the value we choose. And that means like for any canoe, it's going to have the best canoe is going to always have a curvature 0.9. So we'll just do this again, run POSSUM. It's just this continuing cycle. Keep running POSSUM. And it's going to take like around 8 or so tries. Usually, I think the document will tell you which parameters you should change. And you'll probably start off with like 4,000 or 2,000 canoes in the first couple rounds. It's probably take like 8 or so rounds before you have this result. So canoe, when you only have one canoe successfully analyzed, that's when you should stop. And it'll tell you that this canoe right here, and now it's very easy to look at. It'll tell you this canoe right here with these variables will be your most optimized canoe design. And similarly, you'll know the exact specifications of your optimized canoe. So it's a bit heavy than what we wanted, 75 kilograms. It's not a big deal because if it's heavy, that means it's probably stable because it's wider or longer. And you'll know like prismatic coefficient is 0.58. So a bit like fatter than a lot of the other teams, but also slimmer than past U of T canoes. So once you have that number, I'm just going to leave this open so I have a reference point. Actually, it might be easier to read if I have this open because it's the same thing at this point. All the upper bounds and lower bounds are exactly the same. So now the next step is we go analyze a single canoe design, manual input, and then we just enter all the numbers that we have that PANDA already created or POSSUM already ran. So length is 5.5. I'm just going to do some rounding. Like a centimeter is not going to matter. Box smoothing. So yeah. All right, we have this variables entered. So now analyze all aspects. And it'll tell you the same thing for like, low case 1, 3 paddler, low case 2, 4 paddler, low case, and tell you the same thing as the output table. What's important here is they'll give you your actual beam. So remember when I said before that the W in your setup file is not the same as your maximum width, and this clearly shows that we have 0.67 centimeters in our setup file, and then PANDA has said that our actual width beam or actual width is 64.9 centimeters. There's a reason for this. It's because of like some geometry. I don't know if I want to get into this, but PANDA creates some canoes. It creates a bunch of rectangles, and 67 centimeters was the width of one of those rectangles, but it's not because of how tapered we made the canoe. It didn't actually get to that wide. It's now actually 65 centimeters wide. And in some cases, you can have canoes that'll be wider than what you wanted. So we've even had cases where the canoe was 5 centimeters wider than what we planned for. So you always want to make sure that you report this number because that's more important. Because this W, it doesn't really mean much. It's related to the width, but it's not really the width, and we only use it for defining the variables similar to like LP or LF. Those are non-existent, or those variables don't really mean anything in real life, or T1 or T2. So now that we did this, and let's say that you probably want to change up your weighted decision matrix and then find different optimized canoes based on different priorities. So, I suggest run it 5 or so times, and each 5 of those canoes should be different priorities. So maybe you want a canoe that's really fast in the water. So you'll change your weighted decision matrix. And you'll probably want to, let's say, reduce prismatic coefficient down and increase the importance of drag. or maybe you just want to rebalance your points, or maybe you want a different target value. Make sure you do adequate research, but also talk to your paddling leads about what kinds of canoes they want. So assuming that you did all that and you've decided on what canoe you want to bring into the SolidWorks phase, then you need to enter your variables in PANDA just like I did here, and then select output mesh. So I'm just going to type. And then in your file, we're just going to call it PANDA tutorials. Remember, we have to add the txt to the end, otherwise it won't make sense. And make sure you don't put spaces. And let's see, right here is the mesh we created. So looks right now, it looks like just a bunch of numbers, but it actually tells you. So at, let's say, 3.9 meters away from the front of the canoe, it'll give you the coordinates, XY coordinates for the cross section. So, and it does this like multiple different times. So it creates kind of a mesh or a bunch of different lines, and then each lines, it'll tell you the coordinates. So this is really cool because like we're able to create a canoe in so much less time than it would take to just manually do it in free ship or delta ship. So how do we turn this into an actual design? Well, first we need to download free ship. So just search for free ship on Google and you'll find an archived version. And we're not really going to do much with free ship. We just need to turn this mesh into a CAD file. So we're just import surface, find our file, and default options. And we have sort of our canoe. We're not going to do anything with free ship. We're just going to immediately export it. So export as IGS. That's a generic CAD file. Okay, we did that. And then we're going to open up SolidWorks, but we're also going to open up AutoCAD or Autodesk Inventor. So normally I think all 3D CAD software should support IGS files, but for some reason some AutoCAD does not, or sorry, SolidWorks, there's a bug where it doesn't correctly ingest the IGS file correctly. I have some suspicions. So one reason could be that in the way PANDA created Canoe, there might be a gap, or it might not in our surface somewhere, or it could just be a bug in SolidWorks that that never got patched up. So we're going to do a workaround here. So we're going to so this is why we have Inventor open. And we're just going to change this IGS. You can design your canoe using Inventor, but I don't recommend it because it's not as capable as SolidWorks. And I mean, for our purposes, that's fine. But like all of our documents are in SolidWorks. So if you want the maximum amount of help that the team can provide you, it's important. You probably want to use SolidWorks because all of our documentation is based around SolidWorks. So I think default option's good. We have half a canoe here. And then we're not going to do anything in Inventor. We're just going to immediately export this as a CATIA file. And this is so this is CATIA file. It's another format that SOLIDWORKS supports, and you can see it supports IGS2, but as I said, there's the bug that prevents us from directly importing it. And now, hopefully this should work. If not, I'll so if this doesn't work and there's no way around, like there's no way around it, you'll might have to be reduced to design your Canoe Inventor, which is not terrible. Yeah, there's some errors, but I think this should be okay. And yeah, right here you can see we have half a canoe. Just want to change the contrast on this. And I'm just going to I'm not going to actually make the canoe. There's a separate videos for that that I actually made like last year. But I'm just going to show you for illustration purposes what we actually did. And this is our canoe design that finally get to see it and what it actually looks like, and not just a bunch of numbers on the screen. So this is how we kind of turn those 13 numbers that we have here in your setup file in PANDA. Sorry, not this one either. It's how we turn these 13 numbers into a different set of 13 numbers right here. And then we actually create a canoe. And this basically took us like 30-40 minutes. And this is really gives us U of T an advantage over multiple different schools where they could probably spend a month doing this. We can do basically in an hour and maybe even a couple hours if you want to create multiple canoe designs. So thanks for watching. If you have questions, then I guess you can probably email me. I'm going to still be involved as an alum, but there you go. This is how you use PANDA POSSUM to create a canoe design. And if POSSUM ever fails you, then you still know how to create a canoe design using PANDA. So hope this helps.